Hi there. Welcome to a presentation of calculation of determinants of 3 by 3 matrices. My name is Charles Wasfanim Sipa. Okay, let's say we're given a matrix A, in this case a 3 by 3 matrix, and we want to calculate the determinant of a 3 by 3 matrix. Obviously, the process is going to be maybe very different from a 2 by 2, because 2 by 2 I think is the easiest case. Are we together? Okay. So, but we're going to do something similar. We need to identify again the principal diagonal. I think the principal diagonal, as you can see, is here. That's the principal diagonal. And the secondary diagonal is that. But in a 2 by 2, we get only principal diagonal, secondary diagonal, nothing outside the 2. But here we've got elements outside the 2 diagonals. Then the question is, how do we do that? This is how we're going to do. I'm going to show you two approaches at the moment. Then the third one will be a more challenging one, which we might not have time to do now, but let's see. This is how we do this one. First of all, to say determinant of A, notation wise, we're going to write it this way. These are not brackets, they're straight lines. Please make sure that you don't confuse them when you're writing maybe for a test or whatever. Make sure that you don't confuse them. So now if I now want to write straight lines again, 1, 0, 2, and then I get 2 minus 1, 3, 1, 4, 4. And then you close that bracket there. I don't know whether you feel comfortable writing whilst I'm talking, or you feel comfortable listening and trying to get the thing first time, because you're going to get this recording. So you better pay attention, grasp it for the first time at once. This is how I'm going to do it. I'm going to first of all mark my principal diagonals. And I'm going to do this thing going up. I would like to show you that the principal diagonal has got 1, 2, 3 elements. But also, I've got this parallel to a principal diagonal, but it's got 2 elements. And I've got this parallel to a principal diagonal, but I've got 2 elements. So what we did before with this, the principal diagonal, we found the product. We're going to do the same thing here. We're going to find the product. Let's say this is equals to, I said we're going to find the product. In this case, the product here is going to be 1 multiplied by minus 1 multiplied by 4. Then that's a complete with 3. But these other 2 parallels, they don't have 3 factors. The question I would have now, where am I going to get the other factor? I'll just turn around here and compensate that parallel with this factor. Then I'm going to have 0 times 3 times 1. Are we there, guys? Do you see what I'm doing? You don't need to understand this. You need to see it, how I'm doing it. Then this is, I put a plus there. Then come to this parallel. I see they've got 2 factors, so I'm going to cross here and compensate with that. Then I'm going to have a plus 2 times 4 times 2. Then this is the sum of the products along the principal diagonal and its parallels. Am I making myself clear there? Okay. Then I'm going to say minus, like before, it was principal diagonal product minus secondary diagonal. So I'm going to have here a new bracket there, then start on the other diagonal. Let's go this way. I've got 3. Then when I come to this parallel, I've got 2. I will compensate like before with this one. Do you agree? Then I come to this parallel, I've got 2. Then I'll compensate with that one. Then I want you to give me what I should write here. 1 by 2 plus 2 by 0 by 4 plus 4 by 3 by 1. Then I close the brackets there. Then what will follow now is the calculation. This is a 0, if we can see. That's right. This is a minus 4. This is a 16. That's right. Is it 16 or minus 16? 16. 16 minus 4? 12. Minus. This is a 0. This is a 12. That's right. This is a minus 2. What's that? 10. So minus 10. Then this is what? 2. What type of matrix is this? Non-singular. Okay, so that's the determinant. That's one approach. Are we happy? Are we happy? Okay. Right. Our second approach is slightly different, but it's exactly the same thing. You'll see exactly the same products, but the arrangement is the one which makes it maybe easier for some people, maybe more difficult for some people. But I'm not here to advertise any of the methods. Is that right? I'm not going to advertise any methods. Let me just show you how we're going to do it in another way, if you want. There is the thing. You now want determinant of A. Then you do this. You write your line. You write 1, 0, 2, 2, minus 1, 3, 1, 4, 4. Check that I've not written the line here. Then I just draw a kind of a dotted line. I'm just marking where my original matrix ended. Then what do I do after that? I repeat the first 2 columns. I'll write 1, 2, 1. 0, minus 1, and 4. Then I put that. Then, this is what we're going to do next. We take the parallels to the principal diagonal. 3 entries. 3 entries. 3 entries. Do you agree? Second diagonal, 3 entries. 3 entries. 3 entries. And I will subtract the products along this from the products along that. Altogether, I'm writing a map there, like I'm drawing a picture which tells you everything what you do. The lines are saying get these products and you add them. These products are going to be added. These products, the red ones, are going to be added. Between these two sums, you're going to find a difference. Am I making my... Then, let's go. You must do it. Then we see that we get the same determinant or we don't get the same determinant. If we're not getting the same determinant, then there's something wrong with it in one of the methods. But these are methods which are valid for that. This is going to be 1 minus 1, 4. That's a product. Plus what? 3, 1. Plus 2, 2, 4. Putting that minus now, there. The plus, this one is there. Brackets, 1, 2, 4, 3, 1, 0. Huh? Yeah, 7. Okay. Okay. So then we do that. This is 0 again. This is 16 minus 4. That is what? 12. If you didn't see 12 before, start complaining. Then here this is 12 minus 2, 10. If you didn't say 10 again, you can start complaining. Therefore, that is 2. It's freedom of choice. Choose your own method which you think is good for your calculating determinants. Which one? I'm not going to support you. They are the same. The only approach and the layout is different, but to some people, one layout is appealing, the other layout is not appealing. That is normal with human beings.